All right, Algebra 3 students, here we are, second video in 1.03, solving radical equations, and we're going to be looking at factoring by grouping. Now, this is something we've looked at before, so I'm just going to give an example here, a reminder example, so that we can remember how to do that. And let's just look at the example. Let's see, x squared plus 2x minus 15. Now, what we need to do is we're going to take the coefficient here and the negative 15, and we're going to multiply those together. So I'm going to just put that there's this 1 here, and then I'm going to highlight that 15 in green and negative 15. And so what we need is 1 times the negative 15, and that equals negative 15. So we're going to break this apart into two pieces, A and B. Okay, so we're going to have A and B, and when we multiply those together, they have to give us the negative 15 right here, which again is the result of taking the 1 times the negative 15. All right, so when we break this apart, it needs to, the A and the B need to equal negative 15, and when we add A and B together, they have to equal positive 2, which comes from right there. So that's where these come from. Let me highlight that negative 15 and show where it comes from. Okay, so what two numbers, A and B, when we add them together equal 2 and multiply them together give us negative 15? One of them is going to have to be positive, one of them is going to have to be negative because the result of the product is negative. So a positive and a negative. And the positive is going to have to be further from 0 than the negative because the result of adding them together is positive. So I could just go through and say, well, let's see. Is it 1 times negative 15? No, because that will not result in 1. It will not result in positive 2 when we add them together. Is it, really we're just focusing on this. So is it negative 1 times positive 15? No, that doesn't work either, because adding them together would be positive 14. Here, adding them together would have been negative 14. Neither of those is 2. I can't multiply 2 by anything to result in 15. No whole number, that is. So we'll ignore it. Well, what about 3? 3 times negative 5. Well, that gives us a negative 15. But when I add them, when I do 3 plus negative 5, that gives us negative 2. So that's not 2. But what about when I do negative 3 times positive 5? When I add those together, I get negative 2. And then when I multiply them together, I get negative 15. So that works. So that tells me that I can break my 2 apart into a negative 3x plus 5x minus 15. So notice that I just broke this 2x into two pieces that equal 2x. Okay? And I did it using this process right here. Now, what I need to do is notice that there's nothing, when I look at this, the only thing I can factor out is the x. X squared is divisible by x, and negative 3x is divisible by x. So I factor out the x, and when I do that, x squared divided by x is x, and negative 3x divided by x is negative 3. Now, I have to do the same thing here, but what I can factor out here is going to be a positive 5. So I add 5, and I say, all right, 5x divided by 5 is x. Negative 15 divided by 5 is -3. So what I've done is I've rewritten this part right here, and I've rewritten this part right here by factoring. And the important thing to notice is that these two are equal. If they're not equal, then something has gone wrong or it can't be factored. So now I can take my x plus 5 and I will write that x plus 5, and then the x minus 3 goes right here. And I have now factored the original expression by grouping. So that's how factoring by grouping works. And sometimes we need factoring by grouping in order to solve a radical problem. So let's look at an example here. If we have the square root, let me zoom in a little bit, the square root of x plus 9 minus 7 equals x. I can't start off by squaring because I have this outside of the square root, so I can't start off by squaring. So I'll start by adding 7 to both sides, and the result will be the square root of x plus 9 is equal to x plus 7. And now that on the left-hand side, everything is under the square root, I can square both sides. And this is where we're going to start running into a more difficult kind of a problem. So on the left-hand side, we just have x plus 9 because the square and the square root undo each other. And on the right-hand side, we have the quantity x plus 7 times the quantity x plus 7. That's what it means to square something. You multiply it by itself. Now on the right-hand side, we're going to use FOIL. First, x times x, that's x squared. Outers, x times 7 is plus 7x. Inners, 7 times x is plus 7x. Lasts, 7 times 7 is 49. Now we need to get all of our terms on one side and the other side equals 0 whenever we're dealing with quadratics. So I'm going to, well, first let's combine terms there. So we have x plus 9 is equal to x squared plus 14x plus 49. So now we can subtract an x, and we'll get 9 is equal to x squared plus 13x plus 49. Subtracting 9 from both sides, we get x squared plus 13x equals 40. Oh, excuse me. I just did something really messed up there. This is equal 0 now because 9 minus 9 is 0. And this is going to be plus 40. All right, so now we're at this point where we have the quadratic equal to 0. And so we're going to factor by grouping. So again, we have the 1 here times 40. So 1 times 40 is 40. So we're going to need two numbers that when we add them together equal 40. And when we multiply them together, I said add, I meant multiply. And when we add them together, we get the 13. A plus B is equal to 13. So that's where we're at right now. Two numbers that when we multiply them together give us 40 and add them together give us 13. They're both positive because the result of multiplying them is positive and the result of adding them is positive. So they're both got to be positive. And it's going to be 5 and 8. 5 times 8 is 40. 5 plus 8 is 40. 13, excuse me. So this is 0 is equal to x squared plus 5x plus 8x plus 40. And now we're going to to continue by factoring out the x here. So when we factor an x out of this, we get x plus 5. So x times the quantity x plus 5 gets us x squared plus 5x. When we factor out the x, that's what we get. Similarly, here we can factor out an 8. So plus 8 times the quantity. 8x divided by 8 is x. 40 divided by 8 is 5. Notice they're the same. That's important. X plus 8 is one of our factors here, times the quantity x plus 5. So now what we have is a binomial times another binomial equals 0. That means one of those binomials has to be 0. It's the only way that we can have a 0 as the result of a product, according to the zero product property. So we can set each of those binomials equal to 0. Subtracting 8, we get x equals negative 8. Subtracting 5, we get x equals negative 5. So we have two solutions here. And now what we need to do is check them, because one of them might be extraneous. Extraneous means extra, doesn't work. So I'm going to highlight my solutions in red. And let's see, how about also orange? Are those different enough? Yeah, they're different. All right. So first we'll start with x equals negative 8. So we have the square root of negative 8 plus 9 minus 7 equals negative 8. And negative 8 plus 9 is 1. Minus 7 equals negative 8. Square root of 1 is 1. Minus 7 equals negative 8. 1 minus 7 is negative 6 equals negative 8. Huh? That's not right. No. That means that negative 8 is an extraneous solution. Because it turned out to be not true when we checked it, it's an extraneous solution. All right. So now we're going to plug in negative 5 and see if that comes out to be true. So we have the square root of negative 5 plus 9 minus 7 equals negative 5. Negative 5 plus 9 is 4. Minus 7 equals negative 5. Square root of 4 is 2. Minus 7 equals negative 5. 2 minus 7 is negative 5 equals negative 5. And that is a solution. So this is our only valid solution. And that is how you can solve a radical equation where factoring is required and it has an extraneous solution.